Every now and then you'll read the words, "we are made of stars." And a lot of people don't get that. A lot of people don't get what that means. I think, mostly I talk about leadership and motivation and things like that, but today I'm going to talk about something that's one of the most beautiful things in nature. I think to me it's connected to leadership. And I hope I get the details right because it's been a while since I studied astrophysics. So we all know that the Big Bang, at the beginning there was a Big Bang. The whole universe was expanding from a tiny little point. And at the beginning it was so hot and dense that nothing could stick together. It was just a big molten bunch of primordial soup. As everything expanded, when gases expand, they cool off. And eventually all this primordial stuff formed into eventually the stable things that could form, the stable particles, mainly protons, neutrons, electrons, photons. The details of those aren't that important, but for us right now, you probably know that a proton is actually the same as a hydrogen nucleus. So once things cooled off, the universe was basically a big bunch of hydrogen gas. A few of the protons stuck together and you'd get helium, so it's mostly hydrogen with trace amounts of helium. Now this was confusing for a while because if you look around Earth, it's mostly iron and we're made out of carbon and things like that. There's not a whole lot of hydrogen and helium that we're made out of. I mean, it's in the water and so forth. So what happened? Why is there so much non-hydrogen helium around? So people tried to figure out how heavier things got made. And what we found out was that this hydrogen gas was pretty uniform, but every now and then there'd be a little bit more dense in one area than others. And dense mass means there's more gravity there. So gravity would cause hydrogen to come together in certain areas where the density was. And if enough of it came together, it would come together. And even though the whole universe was expanding around these dense parts, it would contract. And if you had enough hydrogen to come together, it would get so hot and dense that you'd get fusion forming, and that would be a star. So a star is held together by gravity pulling the hydrogen and helium in, and then the fusion, the hot pressure pushing it outward. So you'd have these stars, and inside the stars, fusion, I'm not going to go into the details, but the main picture is that it takes different elements and they come together and sometimes they stick together, and hydrogen becomes helium, helium becomes lithium, beryllium, and heavier things, including carbon and oxygen and so forth. And so the insides of stars, you would get denser, heavier and heavier elements until in the middle you have iron. Every now and then, and by the way, these stars formed by the tens of billions in these galaxies all over the place, all over the universe. So as they come together and form heavier and heavier elements, every now and then a star will do what's called a supernova, what happens is the star rips apart, and for couple days, a single star is as bright as an entire galaxy. A galaxy can be 10 billion stars, so it's very rare that you have something happen over the course of days in the universe, and for that matter, for one star to be 10 billion times brighter than it normally would be. But that would happen, and the net result is the star rips apart, explodes, and now you have all the stuff that was inside the star, not all of it, but a lot of it moving out into space. So it's not moving into space, and it's mixing up with all the stuff that's already there. So sometimes that gas that's moving around does like the hydrogen did before, and some parts will be dense, and it will compact, the gravity will cause it to form again into a new star. But this time it's starting off with different elements inside of it than the original star. So these are called second generation stars, type 2, I forget the name. Type 2 stars, I think it's called. So they're second generation. Anyway, these are stars that have different chemicals inside them than just hydrogen and helium. So they look somewhat different. And also, a lot of times, the gas, some of the gas congeals into the star, but some of the gas doesn't quite make it into the star. It kind of moves around, and some of that gas is iron and nickel and things like that, and that forms into planets. And so one of the stars that form this way, with this other stuff going around it, is our sun. And what the Earth is made of is the stuff that didn't fall into the sun, but was once inside another star. And that is what the Earth is made of, and that is what we are made of. And so when someone says that we are made of stars, or we are star stuff, it's because all of the non-hydrogen, non-helium stuff that we're made of was almost entirely made inside another star that exploded, reformed into our sun, reformed into the Earth, Jupiter, and all the other planets, and eventually reformed into us.